So I realized that in my video on area of regular polygons that the sound started messing up at this point at about 10 minutes. So I'm going to do the rest of that video in this one. Okay, so I'm going to redo this one with the Pentagon. Okay, so Pentagon, they gave us this right triangle. They gave us half of that central angle was 36, and they told us the height of that right triangle was 4. All right, so we already know most of the pieces we need to find the area of that triangle. So we really just need to find the base of that triangle. So we're going to use SOHCAHTOA, and x is opposite of 36 and 4 is adjacent, so that means I'm using TOA, tangent. So tangent of 36 is equal to x over 4. We're going to multiply both sides by 4, and if I do that on my calculator, that gives me 2.91 for my x. So this piece right here is 2.91. And remember that cuts this main triangle in half, right? So this is also 2.91. So a full side, or the full base of this triangle, is going to be 2.91 times 2. So that'll be 5.82. So that's our base. Our height is 4, so that we know that a single triangle is 1/2 base times our height. So if I do that on my calculator, I get 11.62 for a single triangle. Now in this one, we have a pentagon, so how many triangles are we going to have? We're going to have 5 of them. So I need to take 5 times my area of the triangle. So if I do that, I'm going to get 58.12, and that's going to be the area of the polygon, or of the pentagon. All right, so that's doing it a little bit differently. And now we're going to do, again, a pentagon, but we're given a different piece of information. So now we're given the radius, and keep in mind that that means if I draw that these are 12. Okay, so I don't know the height of that triangle, and I don't know the base of that triangle. Now, something that it feels like they don't know, that we don't know what it is, but we know that that central angle has to be 360 divided by how many. Remember, there's 5 triangles here, so I've got to do 360 divided by 5. That gives me 72. So this is a 72-degree angle, and then on this triangle that we're cutting in half, 72 divided by 2 is 36. Okay, so we actually do know that angle, and keep in mind that that was the same angle as up here when we had 36 right there. So that's actually where they got 36 in the previous example. Okay, so let's draw that right triangle out. I have 36. I know that the hypotenuse is 12, and I'm looking for the height, and I'm looking for the base there, both of those. So let's do the base first. All right, so if I do opposite, x is opposite of tangent of the 36, and 12 is the hypotenuse. So that's sine. Sine of 36 is equal to x over 12. So if I multiply both sides by 12, that gives me 7.05. Okay, so this is 7.05, and that's 7.05. All right, now let's do the height. Now we could do Pythagorean theorem if we wanted to, or I could do cosine. I'm just going to stick with trig for right now. So that's going to give me height over 12. So if I do 12 times the cosine of 36, that gives me a height of 9.71. All right, so this is 9.71. All right, all that's looking good so far. So for my big triangle, my red one, that whole base at the bottom is 7.05 times 2, which is 14.1. And we said our height was 9.71. So the area of a single triangle is 1/2 14.1 times 9.71. So that's 7.05 times 9.71. So I'm getting 68.455 for a single area of a triangle. Let's round that up to 446. Okay. And so we still have a pentagon, so we're going to multiply that triangle by 5 since there are 5 triangles. So the pentagon, area of the pentagon, is going to be equal to 342.28. All right. So we've done a bunch of different examples using triangles, but I want to talk about another way of thinking about area of a polygon, a regular polygon, that is. And first I need you to know this new vocabulary word. It's called apothem. Apothem, the way you say that, it kind of sounds like you're saying opossum with a lisp. All right, so apothem. And all that is it goes from the center and then perpendicular to the side, which that's what we've been calling the height all along, right? We've been making these triangles and that's the height. So the apothem is really the height of that small, triangle. Okay, so if we think about those triangles, let's say I've got a hexagon. So I'm going to have 6 triangles. I'm going to line them up right beside each other. So I got 1, 2, 3, 4, 5, 6, right? Yeah, okay, so I've got 6 triangles. We just now said that the height of one of those triangles, we're calling that the apothem. Okay, and we were doing 1/2 the base of each triangle times the height. And remember, the base of each triangle is simply the side of a hexagon. If I roll all of these together, that would make a hexagon. All right, so I could manipulate them so that they form to make a hexagon if I wanted to. So if each of one of these is a side, okay, then if I wanted to find all of these, think about this. If I have 1/2 the base times this apothem, that's 1/2. What are all of these bases added together? That would be side times 6 of them. So if I do a side times 6, don't we call that the perimeter? Okay, so I'm doing side times 6, which is just another way of saying the perimeter of a hexagon. And then I'm doing that times the height, which we called the apothem. Okay, so here's what I want you to write down. The area of a regular polygon is simply 1/2 the apothem times the perimeter. So if I could go back and redo any of those previous problems and use this formula. So let's do that right now. Let's go back and redo, let's do this one right here. So if I had this was a radius, correct? And I know that I need the apothem and the perimeter. So I would need to know what the side is, and I would need to know the apothem. Okay, so then we need to know what is this central angle, right? Because that's the hidden piece of information that we can always find. So this is a hexagon, remember. So we're going to do 360 divided by 6. That gives me that each of these angles is 60 degrees, which is great. The reason I like that is because that makes each of these 30. So I've got a right triangle. That's a 30, 60, 90 triangle. And I know that the hypotenuse is 8. Hypotenuse is 8, so then the short leg is half of that. That would make that 4. And then the side across from the 60, the long leg, would be 4 times the square root of 3. All right, so this tells me 2 things. It tells me that the side length is 4 plus 4 is 8. So each of these are 8s. All right, and then it tells me that the apothem is 4 root 3. Okay, so if a side length is 8, then the perimeter is going to be 8 times the number of sides, so 8 times 6 in this situation. So that's 48. So all I do to find my area of this hexagon is plug in the formula. 1/2 apothem is 4 root 3, and perimeter is 48. So that's going to be 96 times the square root of 3. And that's a much nicer answer, isn't it? All right, so there you go. We've got the full video now, and hopefully you can take the rest of your notes.